Hi, so welcome to this tutorial which is going to cover UVs and UV unwrapping. I'm going to just give you a brief rundown of what we're going to look at. I'm going to look at basically what UVs are, and then I'm going to start by applying some UVs to this primitive here and to some other primitives that I've got. I'm going to show you how to do different projection methods to apply the UVs. Can use some reference texture grids to show you the results of applying those UVs, and then we'll end up with just some manipulations of the UVs, creating some UV sets, and then exporting the data to a 2D package where we can then create a texture and then put that texture back into the 3D package to see how the UVs can then be used to create textures for characters and models in your game. So first thing is, what is a UV? Easiest way to explain it is obviously I've got a cube here, which is a 3D object, 2D visualization of a 3D object in 3D space. And what a UV is, or what UV mapping is the process where every part of this 3D object is going to be laid out flat, or you could say exploded or peeled like an onion and laid out flat onto a 2D surface, which we can then use for texture mapping. And there's going to be some kind of key shapes that you'll recognize, or when we unwrap it. If any of you've made any paper craft or paper models or any kind of origami, I'm thinking of a cube here. If you take a cube and draw it out on a sheet of paper, you can cut it out and make a cube, and you'll see exactly that UV mapping is the exact same method of that skill that you probably learned as a kid of making a cube from a sheet of paper. The next thing is what are U and V, or what does the letters U and V mean in UV mapping? Well, the name UV mapping is derived from basically makeshift coordinate system for U and V. Meshes or 3D objects in three-dimensional space use X, Y, and Z. And if I actually show you this, if I hit W, there you go. You can see that I've got, then if I go to wireframe, you can see that I've got the X, Y, and Z axis, which is actually shown here. X being red, Y being green, and Z being blue, showing you the different directions of these axes. Now, this works for a three-dimensional object, and if we move it around, you can, in fact, I'm just going to go to my channel box editor. I'm going to just freeze out the transformations. If I select this cube, hit W, put my cursor on the red arrow and drag it, you can see that it's translating or moving in the X translation, or X direction. If I do it in the Z, it moves in the Z direction. If I do it in the Y, it moves in the Y direction. I'm going to just click on these translations, hit 0, put it back to 0. Now for UV mapping, we can only show two directions. We can only show vertical and horizontal. So if you imagine that this cube is going to be unwrapped from a three-dimensional shape and then unfolded or unwrapped or peeled open to become a two-dimensional shape or on a flat sheet of paper, we can only really define the horizontal and vertical directions. We technically have no Z depth, so rather than vertical X and Y, which would be confused with the X, Y, Z, which is for the three-dimensional orientations and movement of our cube, we call them the U and the V. So the U represents the horizontal coordinates and the V will represent the vertical coordinates. And you'll see this more clearly as I move through, but that's basically what UVs are, and why they are called U and V. So first thing I need to do is I'm going to create, if I haven't already, let's go to my material editor. There you go, I've got a material already created. I'm just going to clean up that view. I'm going to apply this to my cube. Press number 6 so it's visible. There we go. And you can see that I have some kind of rough UVs, but they're not very good because I don't see this nice visual representation. If I zoom in on this grid there, you see I've got a nice grid. It's a little bit blurry because it's in the work area, but you can see that it's not represented well here. And what I need to do is I need to apply my UVs to this to make it look correct. So what I'm going to do is I'm going to switch my hypershade to my UV texture editor. So if you say panels, panel, UV texture editor, there you go. It's a nice clear image of the visuals for the UV reference texture grid. Now, the first thing I need to do is choose a face. I'm going to say sub-object mode face. I'm going to select the face. So I select the top face. And I need to apply a new set of UV coordinates so that this image or this visual appears on this top square here. And to do that, make sure I'm in the polygon menu, create UVs, planar mapping, options, because I want to see the options box come up. And right now you can see that it says it's no default UV set selected. The projection is bounding box, and the projection is from the Y, which is correct because that's the axis which is represented here from the top down. I've got key image and width height ratios the same, and insert projection before deforming. So before I do anything else, let's just click on edit, reset settings, and there you go, it resets everything to default. And I am going to click on keep image width height ratio the same because I want to keep them the same all the way around, so I don't end up with different size squares I have to rescale at a later stage. So keep them the same, and I'm going to say I want to project in the Y direction, and I'm going to leave create UV set off for now. I'm going to come back to that and show you how that works. And then the first thing I'm going to say is apply, and I want you to keep an eye on this visual and on this square here. So I'm just going to apply, and you can see that what happens is there's a projection, a UV mapping projection gizmo appears, and it's just kind of floating above the square, and there's the gizmo in this viewport. And what that has done is it's applied that one-to-one, so you can see everything is readable and matching what we see in the UV editor. Now the good thing with this gizmo is if I click on the gizmo, I can actually manipulate it, and all I'm doing is I'm just pulling in these coordinates here, these gizmo handles here, and you can see that I'm expanding the size of the gizmo in the UV editor, which is in fact making the image smaller. If I click on it and pull it out, I'm actually expanding it in the viewport, but I'm actually contracting it in the editor. And if I just come back to there we go. Now if you want, you can actually scale it in horizontal direction or vertical directions. That's the U and the V I'm playing with there. Obviously there's no Z, so there's no Z direction. But what I can do is, if you look for this little red T on this corner, if I click that once, you get the UV coordinate gizmo or axis, and you see that we've got a new type of axis. It looks like the old one, but this one's got squares and arrows and this blue circle. And what it's trying to do is it's showing you multiple representations of things you can do. So if I click on the arrow, I can move the gizmo in either X, and believe it or not, you can move it up in Y, but it makes no difference because there is no Z depth in a 2D plane, so that's why you see no actual visual change here. Now if I move it in the Z, it's moving across. So again, so what's happening is I'm moving it in the U and the V to give me the horizontal and vertical movements. Now I can also click on one of these squares, which allows me to scale in the U and the V direction, or the horizontal and vertical directions. So that was, there we go. And also if I click on the circle, this allows me to rotate. Now the thing is with the rotate gizmo, you can alter how it looks, because what it's doing is, if I just come out to this view, and I'm just going to minimize this window here, what's happening is this is the horizontal view of the gizmo, of the UV mapping gizmo. If I rotate it, and you can actually see it rotate in the Z, the plane is changing its angle of projection, which in fact changes the visual angle of projection of the reference texture. As you can see, as I alter it, you see it's actually expanding it, because what's happening is I'm moving it from a Y direction, which is vertically down onto the plane, to an X direction, which is stretching out the pixels along, or stretching out the UVs along the Y, which is why they're all streaking there, because there's not a lot of detail to be shown. I can actually put that one back, and you can go the other way as well. If you go the other way, it does the same thing. Now you can do that in the rotate it in the Z. I can also rotate it in the X, which is going to be the horizontal and vertical, which is the U and V, and you get that kind of distortion. Now with the rotation, you can rotate in the Y direction, which is the vertical the top down direction in this view. And what that does is, because we don't have a Z depth, but we are allowed to rotate it on the Z, or what would technically be on the Y axis. You can see there it is rotating it either clockwise or counterclockwise. So we can actually play with the UV gizmo to give you different effects. Okay. So that's just using, that was just some manipulation using the planar mapping. I'm just gonna come out of this method. Let's go back and say face, select that again, and do, call up my window. Where is it? There it is. Planar mapping again in the Y. Okay. And then what I can do now is move on and select the other sides. Say face. Planar mapping in the Y. And you can see there I didn't change the direction, because I'm using planar mapping because I'm creating a cube, and planar mapping allows you to map in the X, Y, and Z. So that side, or that face, would see data from the Z axis. So I need to switch that to Z. Apply that. And if I select that side, which again is in the Z, I can do another one. There you go. And this one is going to be in the X. Apply that. That one's going to be in the X. Apply that. And then the bottom one again is in the Y. There we go. And we have one cube mapped. You can see it's totally readable. Now what I've got here is all the UVs for this cube are basically sitting on top of each other. So what that means is, if I was to create a texture or some kind of visual image, it would be the same image applied on all the same sides. And you can see that this reference texture is looking exactly the same on all the same sides, because all the UVs for each one of the 6 sides is sitting right on top of each other. Now you might actually want that if you want to just put the same texture on each side of your cube. But what happens if you don't? What happens if you want to put the numbers 1, 2, 3, 4, 5, 6 on the different sides of the cube and actually see it visually appear? Well, I'm going to just go back to object mode. I'm going to select that. And what I'm going to do is I'm going to show you how to UV map this cube to allow you to see 1, 2, 3, 4, 5, 6 on each side of the cube.